So below I have a couple of examples of ionic bonding and how to work with their charges. So we can see here aluminum has a charge of +3 and nitrogen has a charge of -3. If we look up here and try to find it in the periodic table, we can see aluminum is right here, nitrogen is right here. So it corresponds with the charges that I have above. And so you basically have to simplify the numbers. 3 and 3 simplify to 1, so you just have aluminum nitride. That's it. It's as simple as that. What you do need to know when the charges are different, though, is that the total charge of the cations and anions, the cations are the positives and the anions are the negatives, they should always be equal. So when we're looking at lithium and oxygen, we can see lithium has a charge of 1. Looking up here, lithium has a charge of 1, and oxygen has a charge of -2. So going down, we want to simplify this. So if we were to multiply the lithium, the one ion, sorry, the one charge by 2, and then oxygen, oh, I wrote this wrong. And then oxygen, oh, this is written wrong. So this would be 1 times 2, 2 to the negative. So then that would equal to 2 and 2, and therefore then we know we need two atoms of lithium with the 1 atom of oxygen, which gets to lithium oxide. That's just how it works with that method. But an easier way to do this is if you were to use the crisscross method. So the way the crisscross method works is if we look at lead and oxygen here, I'll just go back to the periodic table. So lead is right here, and oxygen is right here. So lead has a charge of +4, and oxygen has a charge of -2. So going down, if you want to do this the way we did above, we would just do 4, and then oxygen, the 2 would have to be multiplied by 2 again to get 4, and then you know that you need 2 oxygens to go with the 1 lead atom, so you have lead oxide right here. An easier way to do this, if you know the charges, you can just, we call this the crisscross method, where you just bring the numbers over. So we bring the 2 down and the 4 down, and then we have we have 2 leads and 4 oxygens, and then we would just need to further simplify this. So 2 and 4 are both multiples of 2, so then we have 1 and 2, and that's how you get lead oxide, 1 lead and 2 oxygens right there. Again, if we look at sodium and sulfate, sodium has a charge of 1, sulfate has a charge of 2, we bring them down, and then the 2 goes here, the 1 goes here, sodium sulfate, and that's your final chemical formula for sodium sulfide. It's that simple. The crisscross method always works, so it's just a lot easier to do than if you want to use the multiple. It's just another approach if you want to take that approach.